Welcome to clickmyproject.com. Let we discuss about the process texture-based image compression using GLCM. Let me see the abstract of the process. Image segmentation has large number of applications in several fields. Its importance concerns basically in distinguishing different objects or regions inside the image. It can be contour or edge based, region based or hybrid based, consisting of the combination of contour and region based. Here we have considered region based approaches for the study, which is used for the identification of different structures in the images. Basically, an image has shape, color, and texture as its primitives. For region-based segmentation, we consider texture feature as it describes the regions very exactly. Texture is one of the important characteristics used in identifying objects or regions of interest in an image. Texture contains important information about the structural arrangement of the surfaces. The textual features based on great spatial dependencies have a general applicability in image classification. Three fundamental pattern elements used in numerical human interpretation of images are spectral, textural, and contextual features. The spectral features describe the average tonal variations in variation bands of the visible and or infrared portion of an electromagnetic spectrum. We extract the textural based features extracted from the images, which are based on the gray level co-occurrence matrices. The extracted features were then used for the identification of the different regions in the images, which is employed based on k-means clustering. After k-means clustering, the extracted features were classified using k-means clustering k-means classification method in order to identify whether the input images were be given belong to a lawn or a forest region. So based on the features extracted, this classification is employed. The KNN classifier is based on the calculation of the difference between the neighboring feature values, and the k-means clustering classifies the images based on different intensities in them. So as we can see, the similar grass regions have similar intensities and the tree regions have similar intensities. So based on that, the clustering and segmentation of the processes is employed in this procedure. Let us see the flow of the process. The input images were obtained. So we use normal images of lawns and forest regions extracted from Google Images were used in this processes. So the obtained images that we have used were trained. So the process will be executed for the images that were given in the datasets. So the input images were selected. After that, basic pre-processing steps, including the gray conversion processes, filtering processes were employed. So after pre-processing, the GLCM features were extracted from the images. The gray level co-occurrence matrices features. So these are all the texture informations extracted from the images. The textural parameters extracted from the images were more helpful in the identification of different regions in the images, and the identification of the different regions were essential for the clustering of the images. So using that, the clustering processes employed based on the k-means clustering processes. The k-means clustering processes clusters the images based on the similarities in the images in color intensities. So the different intensity regions were clustered in different representations, and based on that, different clusters were initialized and the cluster regions were extracted. So the object regions were clustered as a similar way, and the other regions were clustered in a similar way. So like that, the clustering processes were employed. After that, after the clustering of the processes, the classification of the processes employed. In the classification processes, the KNN classifier processes is employed for the classification of the images. The the classifier classifies images into lawn regions or the other regions based on the features extracted from the images. So these classification processes after completion of the classification processes, we identify whether the input images that we have provided belongs to lawn area or the forest area. Finally, the overall performances of the process is measured by counting the number of pixels segmented in the each regions, and based on the number of countings, we can analyze whether the process is accurate or not. Let me see the running procedure of the process. If you want to run the code, select the file main.m, which is located in the source code folder. Right click it and click on run file. You will get the process started. So first select any one of the input images which is present in the dataset. So we select any one of the images. After that, the process will be started and the process will be completed, and like that. Then first this is the input images that we have given. So in the pre-processing step, the images is converted into gray, resized, and the median filter is applied. After that, this is the GLCM matrices obtained for the input images and different columns. So this is the GLCM coefficients obtained. After that, this is the autocorrelation values obtained for the input images got, and for different angle variations the parameters were obtained and they were represented graphically. After GLCM features, so these are all the GLCM features estimated from our proposed method. So contrast, homogeneity, these GLCM features were extracted from the input. Then this is the finally segmented images, which is based on the k-means clustering employed based on the parameter values estimated using GLCM. So this is the clusters obtained in the input images. After that, the binarized segmentation is M. So this is the binarized segmentation. Finally, we got in this segmentation, as we can see, the regions that were green, more or less green, were represented in black, and other regions were represented in white. So they were degrouped. So the obtained white regions represents the vegetation processes. After that, this is the overall pixel count of the regions that we are then we have outlined the contours regions that we have obtained. So this extracted regions were of the regions that are representing the set. After that, finally the input regions were classified as lawn. So if we give some other processes, means the process will execute based on that. So we can give some for, if we give some forest areas, means then it will be displayed as forest, like that. So this process is classified based on the, so this is classified as forest. This process done based on the features extracted using the GSM parameters and the KNN classification methodologies. Thank you.